Now that the recording has finally been saved, let's go ahead and take a look at this one. We've got 2 times pi. What is the radius? Again, this is going to be the radius of the base, which happens to be 1.5. Very good. If somebody used 3 in there for radius, you're probably going to get a very wrong answer, because radius is just partway across, which would be 1.5. And then times the height of the cylinder, which is 6. Basically, if you do all that work, you get 18 pi square inches. You might have a decimal there, and that's fine. What is it, 55-ish or something like that? So 56-ish. Now that's for how many, though? That's for 1. We need to take that answer times how many we need, which is 30,000. How we know that? It says so right there. So you take that times 30,000, and the number gets kind of big. I rounded to the nearest square inch when I did it. I got 1,696,460 square inches. Do you agree or disagree with my answer? Well, here's once again my problem. Remember what people out there in the so-called real world are saying? People have no visualization of that, and let's face it, not many people have a good visualization of anything that's a million. All right, very hard, right? So what I'm going to show you how to do is convert that. That is a good answer, but I'm guessing many of you have no clue how big that is, how small that is. I like to relate it either to this. The 2 things I'll relate it to this year is this room or this floor, and then the football field are the 2 things I'll relate it to. This one's probably best to relate to this room. So this room we know in square feet, correct? So we need to convert that to square feet. Well, how many inches are in 1 foot? How many inches are in a square foot? Ooh, tough question. 144. How did he get that answer? He took 12 and he squared it. Okay, so 12 inches we know is equal to 1 foot. If I square this side, it's still 1 square foot. I have to square that side. It's 144 square inches. You have to take 12 and square it. So we have to take this answer and divide it by 144 to get how many square feet we're talking about. And we can round to the nearest square foot again. It's probably the easiest thing to do. And what do you get for the nearest square foot? So that's 11,781 square feet of cardboard. Now what's the floor of this room approximately? What did we say that? It's a 30 by 20. So this is about 600 square feet is the floor here. So that cardboard, if it was cut to this size, obviously, would fit in this room 20 times. Sit right on top of each other. We could stack 20 of them in this room to make 30,000 of these itty-bitty things, those frozen concentrate pads. Again, is that a little easier for you to visualize than 1,696,000 square inches? Probably a little bit easier. Okay, so in this room, stacked on top of each other 20 times. Okay. Any questions so far? Yes? As long as you show, the question was, if I rounded earlier and had a slightly different answer, is it okay? Yeah, as long as you show your work and I can see your thought process, it's fine. But if it's just, you know, one of those where a miracle happens and then there's the answer, well, that's probably not the best. So example 3, I told you basically not to go too far ahead because you would be crossing it off. And what I would like you to do is add this problem instead. No, it's just something I have to talk about before I give you the worksheet. Rectangular prisms cause a problem with lateral area. Do you agree that those 2 rectangular prisms look very similar? They have the same measurements, right? Except one's been tipped over. And is it very difficult to tell which one's supposed to be the base if I give you a rectangular prism? Couldn't any of them be the base? So what I'm trying to tell you is if you are given a rectangular prism, it is sitting on its base. It's not going to be like one of these back here where I've tipped it over. Because can you really tell if I give you one of these? Can you really tell if I've tipped it over or not? Not really. So what we're going to do is find the lateral area of each one and then find the total surface area of each one and see similarities and differences. So let's divide it up in the room here. Let's say that as I'm looking at the class, this half of you that are on the right side do the rectangular prism that's on your side, and then this half of the room over here that would be left as I'm looking at the class will do a one that has 6 by 5 at the bottom. Okay, so go ahead, find the lateral area right now. All right, so the key here was that basically if you were on this side of the room, you were supposed to be doing that one. And if you were on that side of the room, you were supposed to be doing this one. So hopefully that clears up any question. But let's take a look. Lateral area. Of course, you're going to use the prism formula here, and so it's perimeter of the base times the height. Well, what is the base? Well, it's this one. I told you if it's rectangular, it's sitting on its base, so it's basically 10 by 5, correct? But if there's 10 sitting in here in front, how much is sitting in the back? 10, and if there's 5 on the right, there's 5 on the left. So what is the perimeter of this particular rectangle that is the base here? 30, because it's 10 and 5 is 15, so there's another 15. So 30 is the perimeter, and that would be meters. Times the height. Well, if we're talking about height, how much does it go up? So then it is 6 meters. And so when you multiply that for this one, lateral area ends up being 180 square meters. Now, those of you that did that other rectangular prism, I'm hoping that's not what you got, because you don't have the same looking prism. Remember, lateral is saying take into consideration those faces going up, right? So those are the ones you're supposed to be looking at. Now, for total area, what we have to do here, or called surface area, is take that answer and add on 2 times the area of the base. The area of the base is a rectangle that is 10 by 5. So the area of that base is, the base is 10 by 5, so the area is 50, right? So it's 180 square meters plus 100 square meters is 280 square meters. So that's if you did the one on the left. If you did the one on the right, you may realize one of your answers is the same and one of your answers is different. At least you should. Lateral area is the same formula. Perimeter of the base times height. But what's the perimeter of this base? 22. Because it's 6 and 5 is 11. You got more 11 more. So the perimeter of the base is 22 times the height, which is 10. So your lateral area over here is 220. I don't know what that is in the middle there. There we go. And that is square meters. Again, does that answer match that one over there? No, because now we're talking about these faces going up. Do you agree those are bigger than the faces that were going up over there? Yeah. The key here is when you get your worksheet, if you get a rectangular prism and they ask lateral area, say that it's sitting on its base. Okay. Otherwise, you're going to get it wrong. Total area on this one, you take the answer you just got, and you add on 2 times the base, and the base is 5 by 6, which is 30. So really, I'm adding on how much? 60, right? So I'm adding on 60, and look how those come out the same. Because to cover this entire rectangular prism and to cover that entire rectangular prism should be the same. Do you understand the difference of why lateral is different and total is the same? Okay, so keep that in mind on your worksheet that you're going to get today. Okay. Any questions? Yeah. Okay. Basically, a lot of times what I do for the base, the question there's the base, as I say 2, and then right here I'll put whatever the area of the base is, and then I just do the 6 times, because it's a rectangle, so I just do 6 times 5 there, which is 30. The only reason I do it that way, because let's face it, could I just go 2 times 6 times 5 in this particular problem? I could. But some problems, the area is not just base times height. Sometimes it's a triangle or a hexagon, and you might want to then just be able to put the area of the base right there and then take it times 2. But I understand what you're saying. Why not just take 2 times 6 times 5 and be done with it? Well, you could have here. It would have worked, but it won't always. So, great question.